Hey everyone, thanks so much for joining me for my session on the Developer's Guide to the Power Platform Galaxy. For those of you that I haven't met yet, my name's April Dunnam, and I'm a Partner Technical Architect at Microsoft. Prior to joining Microsoft, I was an MVP in the Power Platform space, and I'm a fellow Power Addict. I'm an active blogger, and if you'd like to follow my blog, you can do that at www.sharepointsiren.com. I'm also a YouTuber, so if you just search for April Dunnam, you can find me on YouTube, and I have a lot of Power Platform and M365 related videos. If you have any questions after this, please don't hesitate to reach out to me on Twitter at April Dunnam. The agenda that I wanted to cover today is I want to first level set and do a 101 on the Power Platform. Then we'll talk about what exactly is in it for developers. Why would they be interested in working with the Power Platform? Then we'll talk about some extension points, and we'll wrap up with how we can deploy and govern the Power Platform, because I know that's a big question that developers might have. So with that, let's dive right in. So what is the Power Platform exactly? Well, when we talk about the Power Platform, we're talking about Microsoft's suite of low-code technology. These low-code tools span across Office 365, Dynamics, and Azure. With the Power Platform, we're really getting four main tools at our disposal. We have Power BI for dashboards and reportings and analytics. We have Power Apps for low-code application development. We have Power Automate for workflows and business automation. And we have Power Virtual Agents for low-code chatbots and virtual agents. All of these tools are built on top of the Dataverse database system. And we can take advantage of these things called connectors, which are just wrappers around an API that let us connect to various applications and services. The Power Platform also has AI Builder baked into it, so we can bring AI functionality like object recognition and forms processing to the Power Platform solutions that we built. So the next thing that you might be wondering is, why exactly do we need these low-code tools? Well, if we look at some recent studies and statistics, we found that over 500 million new applications will be built in the next 5 years, which is actually more than all the applications built in the previous 40 years. Given that massive number, that's about 5 times more applications than IT departments can deliver right now. And we're seeing about 65% of organizations reporting an application backlog. So one solution to bridge this gap we're seeing in the amount and sheer volume of applications that need to be developed is low-code technology. These tools will help us speed up the process of getting applications out to market. Well, now we understand what the Power Platform is, why these low-code technologies are important, but you still might be wondering, hey, I'm a developer, what exactly is in it for me? Why would I want to leverage these low-code tools? One of the things that I personally love about the Power Platform, coming from a development background myself, is that other low-code technologies are kind of limited in scope. The Power Platform, on the other hand, has what you might have heard called a no-cliffs experience. So while it's geared towards what we call citizen developers often, so these are just developers that don't have traditional development backgrounds, so that they can drag and drop and have a more visual interface for developing applications. But we also have a rich extensibility model for those code-first developers. So citizen developers can take advantage of Power Apps, Power Automate, virtual agents, Power BI, but code-first developers can come in and add integrations like integrations with GitHub, Visual Studio Code, Visual Studio, Azure services, and APIs. And this kind of is leading into an interesting trend that we're seeing, something that we're calling fusion developer teams. So we just said we have this big backlog of applications. These fusion developer teams that we're seeing pop up are giving us the ability to extend our development teams with the code-first developers, the ones that would be writing C# or JavaScript code, and the citizen developers, the ones without the traditional coding experience, but that know how to leverage low-code technology and know the business process really well. And I think an important thing to understand when we're talking about low-code technology in general from a developer standpoint is this isn't a full code or low-code discussion. It's really an and. And that's what the fusion developer teams are driving. How can we leverage full code technology and low code technology together to meet the demand and build the business apps that we need. So a common scenario that you might see where Code First and citizen devs can work together on these things is maybe you have your citizen devs building Power Apps, but you as a Code First developer can come in and maybe create an integration to an API that would be useful to connect to within the Power Apps that the citizen devs are building. Another common approach we see is the Code First developers acting as the architect, making sure that the apps being built are strategic instead of one-off solutions. Now let's move on to the fun stuff. How can we use our Code First skills to extend the Power Platform and bring more power to it? The first extension point that I wanted to touch on is how we can unlock data silos with custom connectors. I touched on connectors briefly in the intro when I was describing what the Power Platform is, but to reiterate on that, all a connector is a wrapper around an API. It's how the Power Platform communicates with services. We have several out-of-the-box connectors to over 400 different SaaS services that we can use and easily connect into within our Power Platform solutions. This obviously includes all the Microsoft 365 products like OneDrive and SharePoint Dynamics, Azure, but also other services like Salesforce, Twitter, DocuSign, Adobe Sign. But what if the service that you need to connect to in your Power Platform solution isn't on this list? Maybe it's another SaaS product that just isn't on here, or maybe it's an internal API specific to your organization that you need to connect to. Well, in that scenario, we give you the ability to create custom connectors. And custom connectors are really one of the easiest and most impactful ways that we can extend the Power Platform, in my opinion. By unlocking those data silos and bringing data from public or private APIs into the Power Platform, you give more possibilities for the things that you can build for your citizen developers. Now, something you might be wondering if you've used the Power Platform before is, well, why would I create a custom connector versus maybe just making an HTTP request with Power Automate to return and retrieve and write the information? Well, there's several reasons, one being simplicity. We have to consider simplicity and reusability in this aspect. If citizen developers, so non-Code First developers, will be using this, it's not super intuitive to know how to make an HTTP call, whereas we're really familiar with using connectors. We just add the connector into our Power App or a flow and choose the actions or triggers that we need to interact with it. This is also beneficial from a reusability standpoint. We build one connector, we can use it throughout the Power Platform, whether it's in a flow or an app. We're also going to get better logging and analytics using a custom connector versus making HTTP calls. And we reduce unnecessary overhead. So if we were wanting to just use this connector, say in a Power App, having to go call a flow to handle the HTTP request just creates additional complexity that could be avoided with a custom connector. Next thing you're probably wondering, this is cool, well, what APIs can I actually connect to with this? So these connectors are going to work with any RESTful API. These can be public APIs, maybe to something like Spotify, or public APIs that you manage in, say, Azure API Management, Azure Functions, web apps, you name it. And it can even be private APIs. The Power Platform has something called the On-Prem Data Gateway that allows us to connect to the on-prem services that we have. So we can leverage that in combination with the custom connector to get access to your private APIs as well. These custom connectors support a few authentication mechanisms. So we have generic OAuth 2.0 and also OAuth 2.0 for services like Azure Active Directory, Salesforce, Dropbox, GitHub, basic authentication, and API keys. Creating custom connectors is probably the simplest when you're leveraging Azure API Management to host your connector. That's because there's built-in integrations with Azure API Management and the Power Platform so that you can seamlessly deploy your connector to the Power Platform. Another really cool added benefit of leveraging Azure API Management to host your APIs and use your connectors from that is the fact that if we're leveraging this new functionality called Microsoft Dataverse for Teams to build Power applications in Microsoft Teams, then we can call and use these Azure API Management backed connectors at no additional cost. So this gets down into the licensing rabbit hole here, but to summarize it at a whole, if you're leveraging, say, a traditional Power Apps application that's built from the Power Apps portal, and you wanted to consume and create a custom connector in there, you would have to pay for additional Power Apps licensing. So at the current time, this is either $10 per user per app per month, or $40 per user a month for unlimited applications. So if you wanted to use a connector in that case, you would have to pay for that. However, with this new Dataverse for Teams functionality that I'm sure there's sessions on about this, we can build applications with inside Teams and leverage these custom connectors through Azure API management without having to pay for any additional licensing. So let's jump over to Power Apps and take a deeper look at how custom connectors work. If we go to make.powerapps.com, you'll see a data option on the left-hand side. And if you expand that out, we'll have a custom connectors option. Now, it is important to remember the licensing thing that I talked about earlier. You need to make sure to leverage custom connectors that you do have a premium Power Apps license associated with your account. So this is where you'll go to create new custom connectors or to manage the connectors that you've already built. If we click the new custom connector button, we'll see all the ways that we can import custom connectors. We can actually create new ones from scratch with the blank option. We can import from Azure or open API files, even a Postman collection, and from GitHub. The import from GitHub is actually an interesting one. So there's an open source repository for connectors. So you remember those connectors that I talked about that were already built and out there available to use? Those are actually open sourced, so we can go and make changes to those connectors if we need to, and you can add your own connectors as community connectors in this repo. So if you click on the import from GitHub option like I have here, you'll see a link here to explore the open source repo. So that's out there on GitHub. We'll see that we have certified and custom connectors. So if you did create a connector to a service that you wanted to share with the overall community, we can actually upload that here into the Power Platform Connectors Custom Connector repo. When you do that, we get the benefit of being able to easily import that with this option here in the connector screen. So you would just choose the connector type, whether it's one of the certified connectors or a custom. You would select the branch and just select the connector that you want to use. So I might choose this activity scheduling one. Click continue. Then that takes you right to the connector editing screen where you can make any changes or fill in any gaps for this particular connector. When you're building a connector, this screen is going to be the same no matter which way that you're importing it here. You'll need to give the connector itself a name, a description, and an icon. And this is important because when you're actually wanting to consume this connector, that's what will show in the connection details. So you see below, we'll choose the scheme, whether it's HTTP or HTTPS, and then we'll put in our host. Then we can move on to the security section where we will define the type of authentication that we're going to be using to connect to this API. This particular example from the repo is using basic authentication, so we would need to provide it with a username and a password in this section. The definition screen is where you'll build out what's actually going to happen with your connector, what actions will be taking place. So this one from the repo has two different actions defined. There's one for getting blocked times and another for creating a new client. Within these actions, you'll define the operation ID and the request and the response. So for this one, I have my post request URL. We can import how that looks from a sample if we need to here. So we can make sure we're having the right headers and the right body. And that will all be displayed here, and we can always click on one of the body properties and edit and make any tweaks if we need to. So as you're seeing here, we can choose whether this should be required or not, and then also the visibility. So this is important when you want to consume this in your applications. So depending on what the parameter is, you can choose if it should be set to none, advanced, internal, or important. And there's a link to some help documentation here that kind of explains a little bit better what those different visibility types mean. None is pretty self-explanatory, it won't show. But internal means that the operations are available but hidden from the user. Advanced would mean that, say in this case, as you're seeing here, you're wanting to use this connector in Power Automate. In Power Automate, we know we have that dynamic content window where we can pull parameters and properties from our flow into an expression, for example. Well, if we have the parameter in the custom connector set to advanced, they'll have to click the See More option before they see your property. But if you choose important, then it will show up here without having to dive into the See More. So that's the main difference that you need to be aware of. This also has built-in testing. So if you go to the Test tab, so after you create the connector, you can actually test it in line here in real time to make sure that it's working before you start trying to use it in your Power Apps applications. So click Create, and now we can fill out the properties, so the date and times. We'll have to create a connection to our new connector first before this will work, and then we can test it. So we just saw how to import a connector from that GitHub repo. This would be the same process though if we needed to create one from scratch. But what about the Azure API management aspect? I said that was probably one of the easiest ways, and it's going to give you the added benefits of being able to consume that within your Dataverse for Teams apps at no additional cost. Let's take a look at how that works real quick. So in Azure API management, if you go to one of the APIs that you have, click the three dots and go to Export. You'll see that not only can we export this to OpenAPI, but we have a new option here for Power App and Power Automate. So this is actually going to create a custom connector for you for Power Apps and Power Automate. So you don't have to go through that whole process that we just looked at. You just host your API here on Azure API Management. You say Export, choose the environment that you want to export this to, and what you want the display name to be, and just click Export. So let's take a look at what that did for us. If we go back to make.powerapps.com and look at our custom connectors tab again, we'll see that we have a brand new connector here for Untapped Get Beer, which was the one that we just created from Azure API Management. So we didn't have to go through the whole new process and fill out all that information. We just clicked a button. Now we have a new connector that we can start using. From the end user perspective, to use this connector, now that you've deployed that, all they have to do is go create a new application, click the Data tab, search for your connector, and click Add. Sharing these custom connectors is pretty easy. Once you've built that custom connector here in your environment, you'll see a download button, and that will save the Swagger definition for you. So all you have to do if you want to use this, say, in another environment or maybe even another tenant, you just come back into this custom connectors page, say New Connector, and import from an open API file. And you would just point it to that JSON Swagger file that you downloaded from your custom connector. We can also use these in things called solutions, which we'll talk about here in a little bit. The next extension point I wanted to talk about was how you can bring additional functionality to your Power Apps with PCF controls. PCF stands for the Power Apps Component Framework. To understand what that is, we first need to understand what components are. When we open up the Power Apps editor and click Insert, we have all these different controls that we can add. Everything from labels and text boxes and pin inputs to drop downs and slider controls, images, audio, and even barcode scanning. We also have the ability within the Power Apps editor itself to create these things called components, which are just reusable building blocks of controls. Good use cases for building a component might be commonly used things like headers, footers, menu controls, things like that. The idea being here with the components that you build within the Power Apps editor, that you can just use the controls that are already available here on the Power Apps editor, like say a label control, and maybe a rectangle for a background. And instead of putting them on a screen like this, if it's something that you want to reuse on multiple screens or maybe multiple different Power Apps, you build that as a component. So we can come into this Components tab, say New Component, and put the controls here so that we can reuse it. Now the only limitation with doing it this way is we can only use the controls that are already available to us within Power Apps. What if we need to do something that there isn't a control for? Maybe we want to export to Excel or print or have an ArcGIS map or maybe a custom slider component. That's where the Power Apps Component Framework can come into play. PCF controls let us take our code-first skills and use that to build controls that we can add on to Power Apps. These Power Apps components are comprised of three different things. We have our manifest file, which contains the control definition. We have the component implementation itself, which will be TypeScript or JavaScript. That will have your user interface and your functionality in it. And then we have the resource files. This could be any JavaScript libraries you're referencing, CSS, local images, things like that. How it works in the back end is we have an interface API, and then we have a control that implements the interface in the UI rendering logic. We can use something called the Power Apps CLI command line interface to create these new controls, and we package those up in what's called a solution file. These solution files can be installed in a particular environment in the Power Platform, and they can be consumed either on model-driven or Canvas applications. So our citizen developers can take these PCF controls that you've built and packaged up and deployed into an environment, and all they have to do is import that into their app and start using it. Let's take a look at how we can use a PCF control that's been built in one of our applications. So after you create the PCF control with the Power Apps CLI, you'll need to package it up as a solution and import that into the environment that you want to use it in. So to do that, you'll go here to the Solutions tab from make.powerapps.com, and you'll click on the Import button. Then you'll browse to the zip file, the solution file that was created for you when you packaged up your PCF control. Click Next, and then Import. Now, if you're wanting to use this particular PCF control in a Canvas app, there is one more step that you need to make sure that you do, and that's in the Power Platform Admin Center. For any environment where you want to use PCF controls in your Canvas apps, you'll need to go to the Admin Center, select the environment, and go to Settings. You'll want to expand out this Product tab and go to Features. And then here in this section, you'll want to make sure you turn on the Allow Publishing of Canvas apps with code components, and then click Save. That way you can make sure that the PCF controls you built will be able to be used in Canvas applications. All right, so how do we actually get these PCF controls into our Canvas apps? So from your app, you'll need to click on the Insert menu, go to Custom, and then Import Component. Now, as I mentioned earlier, we actually have two types of components. There's the type of component that I showed that you can create here from Power Apps itself, and then there are the code components that you will use the CLI for. So if you want to import a code component, you'll click on the Code tab, and this will show all of the different code component solutions that you deployed for this particular environment. So just select the one that you want to use and click Import. Now we've made that available to our app. Now we just have to use it in a screen. So to add in a component, we'll click on the plus button in the left-hand side here, and we'll expand out this code component section. And every code component that I have imported into this app will show up here. So now all I have to do is click on that code component, and it's added into my app, and I can start using it. This particular component is a color picker, which is pretty cool. So if we play this app, we'll see that I have a color picker. I can choose red, and it will spit out the hex value of that. Some other things we can do with code components are things like this iframe control. Again, this is filling a gap with functionality that's currently not there in Power Apps, but we can bring the functionality to all of our users with these PCF controls. So it's a very simple control, just allowing us to pass into this control a URL, and that will surface that up in an iframe in our Power App. So with these PCF controls, we can have different properties that we define. So if I expand out this advanced property on the right-hand side here, you see that we have a source input property where I can just paste in a URL, which I have here to a SharePoint page in this instance. And as soon as I paste that in, it renders the SharePoint page here inside my Power App. Another gap that code components can fill is giving us the ability to export data to Excel. So with Power Apps, you might have what we call a gallery of information, which is just a way to surface up tabular data. And maybe you want to export what we have here to Excel. We can do that with this simple PCF control. With a click of a button, it's going to take all of the data here in this table and output that here to this Excel file. You might have noticed a little print button up here as well. That's another thing that we currently don't have in Power Apps, but that we can do with a simple PCF control. Take the same data that we have in this table, click Print. That opens up a print panel with all of that tabular data. And the cool thing is, all of these examples that I just showed are available on GitHub. The print and the export to Excel were built by Yash Agarwal. So I can give you a link to download those so you can see how they're built and start using those in your applications. So I know I've shown some cool things so far with how you can extend the Power Platform with your code first skills, but I bet you're probably wondering, how do I actually manage the application lifecycle for these Power Platform solutions? We do have the ability to do that with Power Platform, and that's with the functionality that we call solutions. Solutions are used to package up and maintain components that make up one or more applications. They are created and authored by a publisher. You really get the full advantage of this solution mechanism if you're leveraging Dataverse, also formerly known as Common Data Service, as the data source for your Power Platform-based applications. The reason being, if you are leveraging that as a primary data source for your apps, we are able to package up your data model into the solution so that you can easily transport that from one environment to the next or another tenant, whatever it might be. In this same solution, not only will you have your data model, you'll have your user interface, which will be your model or canvas-driven applications, those PCF controls we just looked at, dialogues, so on and so forth. The solutions also contain your process and your code. So these can be your workflows that you've created in Power Automate, custom activities, plugins, business processes, rules. And they can also contain things like security rules to handle the permissions in your solutions, Power BI dashboards and reports, system settings, modules, etc. There are two different types of solutions that we can have with the Power Platform. There is managed and unmanaged. Unmanaged solutions are used in development instances where you still need to make configuration changes to your applications. And these unmanaged solutions should be considered your source. Managed solutions, on the other hand, are used to deploy your solutions outside of a development environment. This could be your UAT or production environments. These should be generated by a build server and considered a build artifact. We also have the concept of solution layering. This occurs when you import a solution. So we looked at with the PCF control how we imported that solution into our environment. When we did that, we could have layering of dependencies. These are created through the extension of an existing component or through the creation of a new component or a version of a solution. The other thing that we can take advantage of with these solutions are something called environment variables. So consider this kind of like a config file for our Power Platform-based solutions. These allow us to migrate application configuration. We can use configurable input parameters in our model-driven Canvas apps, our flows, which will allow us to update these without modifying the components directly. Now let's take a look at how these solutions actually work and what they look like. So we'll go back to make.powerapps.com and we'll go back into that solutions tab. Now we just looked at how to import one, but what does an actual solution file look like in here? As you can see, I have several solutions here, and let's dive into this conference one and we'll see what is in this particular solution. So for this one, I'm going to sort this by type just so we can see what's included. So you can tell I have one Canvas application as part of this. I have a model-driven app. I have several tables where my data is being stored. I have a sitemap for my model-driven app, and then we have some choice fields that are being used in my tables. With these solutions, we can add existing or create new items directly inside a solution. So if I know that I needed to add something to this conference application solution that I'm building, maybe I need a new table so I can track session evaluations, I can just go to New, and you can see all of the different assets that we can add inside of these solutions. One of them being a table. So right from here, I could say create a new table called evals. Click create and build out any columns and information that I want to store in this table. So I might have a rating field, for example. Click done and save table. Now this is automatically a part of my solution. If you've already built something outside of a solution and want to include it in it, we can use the add existing. And perhaps I wanted to add in another Canvas application into the solution. I can choose the app and Canvas app option here. And this is going to show us all of the different Canvas apps we have. So we have two different tabs. So we can see Canvas apps inside other solutions. Or we can click outside solutions, which will show all the other Canvas applications that I have. I'll just click the app, click add, that gets added into the solution. We talked about environment variables, so if we click New again, we'll see the environment variable option. This is where we can specify those input parameters, so we can create a new environment variable, and it accepts a few different data types. So we can use environment variables for decimals, text, booleans, and even JSON. We talked about custom connectors earlier. You can actually include those as part of an overall solution as well. So if I go to Add Existing and scroll down, we see an Other option. There's an option here for custom connector. So if I was utilizing a custom connector, say in one of these Power Apps applications, I could reference that in my solution so that it gets carried over as well, just by clicking Custom Connector and choosing the connector from this list. Now, once I have my solution built and ready to go and everything added to it, if I want to package this up and deploy it, all I have to do is click Publish All Customizations. And then now that that's published, we can export this solution. And there's even a testing mechanism that we can run, this check for issues that you see here, which will evaluate your solution and check for any issues, maybe missing dependencies or whatever it might be. But all we have to do to export is click Next. And this is where we would choose that option. Are we exporting this as a managed or unmanaged solution? So say if we wanted to put this into some kind of source control, we might export this as an unmanaged. But if we were wanting to move this to production or a testing environment, we would choose the managed option. We also have versioning here, so it's recognizing the latest version of the solution and incrementing it automatically for me. Now if we click export, that's going to generate a zip file that contains the solution. Then once we have that, we just go through the process we looked at earlier with the PCF controls and importing that solution, and all the assets will be carried over. Now I know that probably seemed like a really manual process, but the good news is we actually can automate this process to some extent with managing these solutions, thanks to Azure DevOps and the Power Apps Build Tools. Power Apps Build Tools is an extension that you can get for Azure DevOps that help you automate the build and deployment of your Power Platform solutions. This is going to help you synchronize solutions between development environments and source control, generate build artifacts, deploy to downstream environments, provision, deprovision of environments, and there's a cool Power Apps checker service that lets you perform analysis against your solutions. So how the general process can work, you have Azure DevOps, download those Power Apps build tools, create a build pipeline to export from dev. Then you can create a build pipeline to generate that build artifact and create a release pipeline to deploy to production. So you see the jobs in the pipeline that we can run here with the build tools. So we have the tools installer, we can export solution, unpack a solution, and commit the solution to repo. We can do things like importing an unmanaged solution, so your source code, and then exporting that as a managed solution so that we can take that and deploy it to production. So it's pretty cool to see all of the stuff that we can do with these solutions and the integration with Azure DevOps to automate the deployment of our applications. Another thing you might be wondering though is, do we actually have control of the source code of our Power Apps applications that we build? Now we know with our Power Apps, we don't build those in Visual Studio or any CLI or IDE. We do that all through the GUI and the Power Apps application. We can share these and export these into solutions or exporting a package to move that into a different environment, but we still don't technically have the source code. Well, now this story became a lot more interesting thanks to some new functionality released just a little bit ago that allows us to access the source files for these Canvas apps, Power Apps that we built. Our Power Apps applications are stored as a .ms app extension. What this new tooling does is it unpacks that MS app file into all of the source files for us. So this not only gives us the ability to edit these source files directly in something like VS Code, which will be really beneficial in, say, scenarios where you need to copy and replace text throughout your entire application, perhaps. It also means that we can collaborate on our Power Apps more easily. But one of the things with Power Apps right now is we do all the editing here in the browser in the Power Apps application. If I'm opening this application to edit it right now, that means none of my colleagues can be in this app at the same time. If someone else tries to go and open this, they'll get a message that it's locked for editing by me in this case. Similar to if you were trying to both edit an Excel document on a file share. So you can see how that can kind of put a kink in any kind of real collaborative development that you want to do. But with this new functionality to take these source files, multiple people can be editing this or a different section of this at a given time, and you can just package it back up and merge all of your changes. Leading to the main thing that this really is helping us with is being able to manage our source code with GitHub. So now we can take advantage of everything that GitHub has to offer. Branches, pull requests, merging, diff changes, all of that. It's really easy to get started using this. The only prerequisite that you'll need is to make sure that you have the .NET SDK installed, at least 3.1, and I believe it's backwards compatible if you have a more recent version. And then you'll need to clone this repo that has the tooling in it. So I've already cloned that down here and have that on my desktop. So what you want to do after you get this cloned down onto your local machine is run this build command script so that it will set up everything that you need. Now, to get an application ready for you to unpack its source files, you need to save the app as an MS App file to your local machine. So take this meeting capture app that I have. So I have it open up in edit mode in the Power Apps editor. So if I go to File and click Save As, and instead of saving it to the cloud, I'll choose this computer option. And then that'll pop up this dialog where I can download this MS App file. Now that I have that, all I need to do is open up Command Prompt, and where you clone the repo on your machine, you'll want to go into the bin folder, debug, and this PASOPA folder, because that's where the executable is. So we'll actually want to navigate to this path from the command prompt. So we'll do a CD and paste in that path there. And now we can execute the command that will take our Power Apps MS App file and unpack it for us. Before I do that though, I need to create a location where I want to unpack the files to. So I'll go here and I'll do a new folder and I'll call it Meeting App. For the command I'm about to run, I need to know the location of the MS App file I want to unpack. So I'm just going to confirm the name of the file and where it's at. So now I'm going to type PASOPA space hyphen unpack. And now we have to point it to the location of the MS App file we want to unpack. And then we'll do a space and put the location where we want to unpack the files to, which is that new folder that I created. And that will run and unpack the files. So now if I navigate back to that new folder that I created, we'll see all the source files here. So if I go into the source folder, what it does is it will take all the screens that you have in your Power Apps application and produce YAML files of those for you so that you can edit those. So if I wanted to make a change to this home screen, I can click on that file, open with code, and see all the code from my Power App. And now that I have this source code, I can add this to my GitHub repo to manage. So from GitHub Desktop, for example, I can add a local repository, browse to that Meeting App folder that I just created, create a repo in there, click Publish, and now I can see all of my source files here on my GitHub repo. Another thing you might be wondering is, how do I test my Power Apps applications? We all know debugging is half of the work when developing an application, so it's important to have the right tools. Thankfully, Power Apps has some great built-in tools for this. So if you open up one of your Power Apps in edit mode, you'll see this little icon, and if you hover over it, it says Advanced Tools. So we have two different things that we can use to help test and debug our applications. We have something called Power Apps Monitor and Test. Test actually allows you to run unit tests for your Power Apps applications, whereas Monitor will help you run and attach a debugging session so that you can see exactly what's happening as you run through your app. Test is still experimental, meaning it's not fully released, but Monitor, just a little while ago, was made publicly available. So let's take a look at Monitor. If I want to see what's going on with this app, I can open the Monitor here, and this is going to open up a monitoring session. So all I have to do is run my application through the studio, click around, perform some actions, And while I'm doing this, the monitor is running in the background, picking up every click that I'm making. So now if I go back to that tab with the monitor, we'll see everything that I did with timestamps, category, whether it was a user action or a function, what the operation was. So in Power Apps for this, I did a select, and the result, whether it was successful or it failed. I can click into any of these, and we'll see some more details as far as what exactly was going on, what did this select action do, and the formula that was going on behind the scenes. Oftentimes in the app itself, we might get really vague errors, so the monitoring session is going to help you really debug and see exactly what's going on and get more detailed errors. The cool thing about this monitor is the ability to invite others to a monitoring session. So if I click this Invite tab in the upper right-hand side, I can enter in someone's name and invite them to the session so they can see real-time what's going on and help debug with me. We also have a Connect User option. So if a particular user submitted a ticket that they're having an issue with your application, you can send them a link to a session here, and it will allow you to watch real-time as they run through a scenario, run through your application, and see what's happening in the monitor. All right, so we've covered a lot in our time here. We did a little Power Platform 101. We talked about why devs should be interested in it, some extension points of ways that we can extend the platform, how we can manage our solutions and source code, how we can debug our applications. And the last thing that I wanted to address here is probably a big burning question. This is great, but how do I manage a Power Platform environment? It seems like if we're opening the gates for everyone to create apps, that it could become out of hand. So it's a valid question. Well, thankfully, there's lots of built-in tools that we can use. Earlier in the session, we looked at the Power Platform Admin Center. Well, part of the Admin Center gives us some logs and analytics that we can look at to help us see what's happening in our Power Platform environments. We can get admin analytics, like how many environments we have, what capacity we have, things like that, and maker analytics. So this goes all the way down to what Power Apps do we have in there, what flows, how many people are using them, what connectors are they using, things like that. We can also leverage management connectors and PowerShell to bring in our Power Platform implementations. Management connectors are actually part of Power Apps in Power Automate. So there's a Flow management connector, there's a Power Platform for Admins connector, there's a Power Apps for Admins, Power Apps for App Makers that we can use to administer the Power Platform. If you prefer PowerShell, there's a link there to all the information you need to know about the PowerShell commandlets that are available to help you manage Power Platform that way. I'm a big fan of the management connectors because they really help you use the Power Platform itself to manage the Power Platform. So a common use you'll see for this is with Power Automate. So you could have, say, a recurring flow that runs on a schedule that can go out and look and see how many new applications or new flows that you have built or environments that were created and get alerted on that. That way you can be aware and proactive to manage all of the solutions that are being built in your environment. And lastly, as far as managing your Power Platform implementation, you should really consider installing the COE, or what we call the Center of Excellence Toolkit. This COE toolkit is going to give you a lot of benefits. There are some core components that are going to help you manage your DLP policies, do things like change app ownership, because one thing that you might run into is as you have more and more people building apps and flows, you have to worry about orphaned applications and flows. So if someone builds something and leaves the company, what happens? Well, with this COE toolkit, there's some built-in functionality that enables you to easily assign co-owners and change app ownership. There's some compliance pieces as well. So you have sample audit processes, ways to archive unused applications, and act based off of certain connector usage. And it really goes beyond just the auditing aspect of things. It has these nurture components, so it really gets into overall governance and nurturing of your Power Platform environment. There's templates to help you onboard new makers, and even provide training and share best practices, have an app template hub, and different things in there that will really help encourage adoption of the Power Platform as a whole. All right, so that's all that I really have for you today. I did want to leave you with some resources. So there's a link there if you want to know more about that Power App source code tooling. There's a link to the Power Platform build tools for Azure DevOps, a PCF gallery that has a bunch of PCF control component samples, and the Power Platform connector repo. Thanks for watching and enjoy the rest of the sessions.